Hello everyone, welcome to episode 37 of Reconstructing Cave Story. In this episode we're going to be looking at our polar star projectile and its collision with walls and how it should behave when that occurs. But first of all, I did a couple of minor off-camera adjustments. First of all, I added a new make file for those of you running Linux or Mac OS X. This should be way more efficient than the one I was using before, but I didn't ever end up updating it until now. So yeah, go for it, have at it, take a look at it. Don't use it if you don't want to, whatever. Another thing I did was I got rid of the map update. We weren't using it, so we didn't really need it anymore. I changed the sprite update and the animated sprite update, so neither of them take in elapsed time. Again, they don't use them anymore because they are using timers which get updated by themselves in the timer update all method, static method. So those are just a couple of minor off-camera adjustments I decided to make. I didn't really feel like they needed to be done in the episode because none of them are very interesting or complicated. But you can check them out. I'll put a link in the description for my GitHub repo. So now for the actual episode. The problem we're going to be solving is the projectiles should not pass through walls. They should be stopped and removed from the game when they hit a wall. And then there's a little particle effect, and we'll probably get into particle effects pretty soon here once we do bat death kind of stuff. So yeah, let's look at our solution. So our solution is going to be collision detection. We're going to use the get colliding tiles method. So that means we also need it's map.get colliding tiles, and it takes in a collision rectangle. And so we'll need to create our collision rectangle. So these I just got from the sprite. So when it's horizontal, its width is 32 and its height is 4. But when it's vertical, its width is 4 and its height is 32. So it's just, flipped 90 degrees. Rotated 90 degrees, I should say, not flipped. And then both of them, you can calculate the x and y the same. And the x is wherever our current x is, including our offset, plus half a tile unit. So we can get to the middle of it and then subtract off half of the width. And so this will do correction for us depending on if we're vertical or horizontal, because if our width is 32 and we're horizontal, this will be plus 16 game units minus 16 game units, so the x will be equal to x. This should be y. So same thing for our y. We just add on half a tile unit to get to the center and then subtract half of the height of our projectile to calculate it. So without any more talking, let's get started. So let's start in our player class, player.cc file, and we're gonna need to pass in to our, let's look at update. So we're gonna need to pass in this map object into our polar star. So let's just do that. Easy, done. Okay, so let's go to polar star and take that in to our gun and then take it into our projectiles too. So update projectiles, we'll take map. So let's forward declare map. And let's take it into our projectile update while we're here. And go into polar_star.cc and fix it there. So let's include map up here. Pass it to our projectiles when we update. And then take it in when we update our projectiles. Okay, so here is where we want to check. Let's do our offset and then check collision. So we would do map.get colliding tiles, passing it in a collision rectangle. But we don't have our collision rectangle defined yet, so let's define that first. I'm going to go up to the top and just define a width for our projectile. So k projectile width. And this will be the small width, and it'll be 4.0f, like I said over here. And this is the width when it's vertical. I just chose the smaller, I just chose width over height just because, I don't know, I feel like the smaller one is usually the width, and things are usually skinny and tall. I don't know. I guess I could say short length, but that's just, whatever. It's done. Okay, so now let's create our collision rectangle. So we'll go into polarstar.h and create a private method to create our collision rectangle. So let's call it rectangle, which we're going to need to include lowercase rectangle. And I'll just call it collision rectangle. Won't take anything, and it'll be const. So let's implement it now, or try to implement it, and then see where we run into a problem. Polar star projectile. So here's the problem. What is our x and y? Well, it's not x and y, believe it or not. It is x plus offset, or x minus offset, or y plus offset, or y minus offset. So let's take the logic we made in our get, in our draw, and create a get x and a get y so that we don't have to do same calculations in more than one place. So this will be units of game called get x, const of course, because shouldn't change anything. And let's implement these down in polarstar.h, like right below draw, or how about right below collision rectangle. So let's scope it in. Okay, so let's start with x. So x is going to be x unless it's horizontal, in which case it's going to be this bad boy. So let's do an if check. So if vertical direction is horizontal, let's return this bad boy. So it'll be x plus this thing. So return x underscore plus this whole mess. Otherwise, we're just going to return x. See, that was easy. Yeah, not so bad. Okay, so now let's take care of y, and I'm just going to do this thing right here and just copy it and paste it, or delete it and move it, I guess, and then return y. And then inside of our draw call, we can call get x and get y. And I should really make sure that this is still working since we did a refactoring. So I'll build it and run it. Oh, this has to return a rectangle, so let's just return a generic rectangle. Just so I just want to make sure that our draw call is still working, just because we factored out this get x and get y, and you know, can't always trust yourself, but it looks to be just fine, so I'm happy. Now let's make our collision rectangle, and again, just grabbing it from here, let's start with the width and height. So let's define a width, so units of game, this can be const for width, and this will be equal to if horizontal direction, or vertical direction is horizontal, then we want to say that it's one tile length. So units tile to game 1. Otherwise, we want to say that it's our k projectile width. Let's break this up into another line. And it's the same thing for height, except switched. So I'll just change this to not equal to horizontal. So then we can calculate our x, again how I said. So 1 plus 1/2 tile unit minus width over 2. So get x plus units k half tile minus width divided by 2. Same thing except for get y. Actually, I'll just copy and paste it. So get y and height. And then these are easy because they're just width and height. There we go. Okay, I'm gonna build it just to make sure I didn't introduce any bugs. Great. So now we can go back through and actually go back to our update and actually use our get colliding tile. So how about after we calculate our offset, let's call get colliding tiles from map. So map.get colliding tiles. And it's going to return a standard vector of collision tiles. So let's store those. Standard vector of map collision tile. We'll call them collision tiles or colliding tiles. And fill it with map.getColliding tiles collision rectangle. Nope. Rectangle. No, collision. There we go. And then we can loop through and see if any of them are wall tiles, because remember we have the entire thing is full and it's just most of them are air tiles. So let's look for wall tiles. So for size t I equals 0, I is less than colliding tiles dot size plus plus I, if colliding tiles sub I dot tile type is equal to map wall tile, then we want to well, remember, we have this update method which returns true if we are live, so we can just return false in here because we have died. And we being the projectile. So return false in here, and that should be good. We can't just return this statement because if it's true, we can't just do that, returning that, because if it's true, then it'll cut out too early and it'll just keep flying as long as there's an air tile. So that's something to look out for, I guess. Not logically equivalent. So let's see how this looks, and let's shoot down, and yes, it looks great. So good. It would look even better with particle effects because you could see the point of impact and everything, and we're going to do that soon, but I have a few things I want to do first before that comes. So anyway, this is the end of the episode. Thanks for watching, guys, and happy developing.